You know, there are some things you see all the time, but you don't really see them. Today, we're going to dive deep into one of those things, the massive world of industrial storage. This is the invisible backbone that, believe it or not, is quietly powering pretty much everything in our modern lives. All right, let's get into it.
So, let me ask you a question. Think about the fuel that gets you to work, the clean water that comes out of your tap, even the food you eat and the chemicals and products you use. What on earth is the one single thing that connects them all?
You guessed it. Before any of those things get to you, they all spend some time right here, inside a vast, hidden network of industrial storage. And this is so much more than just holding stuff. It's really about guaranteeing that our entire global economy keeps running smoothly.
To really get a grip on this, you have to understand the sheer scale we're talking about. I mean, this is not some small-time operation. This is a colossal, globe-spanning system. Just look at that number. That's over 1.6 billion cubic meters. It's almost impossible to picture, but that is the total known storage capacity of this network around the world. It is the absolute backbone for our most critical industries. We're talking energy, chemicals, you name it, even agriculture.
And here's the wild part. It's growing like crazy. Just look at this timeline. The number of these storage terminals has more than doubled in just 5 years. And that tells a really interesting story. It shows this huge strategic shift away from just-in-time logistics to, building up real, tangible resilience.
This quote from the Panorama Mondial report just nails it. The world is finally realizing that having these reserves isn't just about convenience. It's geopolitical and industrial insurance. It's our buffer against supply chain chaos and global shocks, which turns these big metal tanks into truly strategic assets.
Okay, so you've probably heard people use the words tank and terminal like they're the same thing, but they're not. They are fundamentally different, so let's break down the actual building blocks of this industry.
So first up, you've got the storage tank itself. The easiest way to think about it is as a single, simple container. Its job is absolutely vital, but it's straightforward. Just hold a product safely and securely. It's what we'd call a passive asset. It just sits there, doing its one job really, really well. A terminal, on the other hand, well, that's the whole shebang. It's a full-on industrial hub with lots of tanks all connected together. It's an active player in the game, managing the constant flow of products coming in and going out, whether that's by pipeline, ship, train, or truck. It's a critical logistics node.
All right, this comparison here makes it crystal clear. A tank, that's a passive asset, a single unit. A terminal, that's a strategic node, actively managing all the logistics. The analogy at the bottom is perfect. A tank is like a single glass of water. A terminal is the entire city's water grid. See the difference?
But here's the thing. It's not like one size fits all. Not all tanks are created equal. In fact, there's a huge variety of different designs, and every single one is engineered for a very specific purpose, a specific material, and a specific environment. This chart basically gives you the roadmap for how they're all classified. We can categorize them by their physical position, their geometric shape, and what kind of roof they have. And trust me, these are never just random design choices. It is all driven by physics, safety, and efficiency.
So let's start with position. You've got your above-ground tanks. These are the ones you see most often because they're easy to get to for maintenance. But then you've got underground tanks. You see these a lot at gas stations or in crowded urban areas where safety and just plain lack of space are huge deals. Shape is also a really big factor. When you need massive capacity, and we're talking anything over 100 cubic meters or so, the tanks are pretty much always these vertical cylinders. It's the best way to get the most volume on a smaller piece of land. For smaller needs, though, you'll often see these horizontal tanks instead.
Now, let's talk about the roof, because this part is actually critical. A lot of tanks have a simple fixed roof, like the domed roof you see here. They're straightforward, they're cost-effective, and they are perfect for storing products that aren't super volatile, things with high flash points like diesel fuel or water.
But what about more volatile stuff, like gasoline? For that, you need something way smarter. And this is where floating roofs come in. It's brilliant, really. The roof literally floats on the surface of the liquid. This gets rid of most of the empty vapor space and can cut evaporation losses by up to 96%. You've got external versions and then internal ones that have a second fixed roof on top for extra protection. It's just a fantastic piece of engineering.
So how in the world do you actually build one of these giants? And maybe more importantly, where is this whole industry headed? Let's take a quick look at how they're built and what innovations are shaping their future.
Well, what they're made of really depends on what they're going to hold. Welded steel is the absolute king for petroleum and chemicals because it's so strong.
Bolted steel is great when you need to put something up fast, and of course, concrete is incredibly durable, perfect for things like water or wastewater.
Now, building one of these is an incredibly precise process. It all starts at the foundation, meticulously welding together these special steel plates. They're called annular plates, to form a perfect circle that becomes the base ring of the tank. Then, they start building the shell upwards, one massive steel course at a time. They use these temporary braces called strongbacks to make sure every single piece is perfectly aligned for structural integrity before they do the final welds.
And finally, after all that incredibly precise work, comes the most critical step of all, hydrostatic testing. They fill the entire tank with water. It's the ultimate task to check for any leaks and to prove it can handle the immense pressure of whatever it's designed to hold. It's a real testament to the engineering skill involved.
And you should know, this industry is not standing still, not at all. The future is all about getting smarter, safer, and more efficient. We're seeing huge leaps in digitalization and automation to manage these terminals. Robotics and drones are completely changing how inspections are done. And, maybe most critically, the entire industry is working to adapt its infrastructure to handle the fuels of the future, like ammonia and biofuels.
So when you put it all together, we've seen how this humble storage tank has gone from being just a passive container to becoming a truly strategic pillar of the global economy. It's a tool for resilience, for stability, and for powering our future energy needs.
So I'll just leave you with this final thought. The next time you're driving down the highway and you pass one of those sprawling tank farms, are you going to see just a collection of giant metal cans? Or are you going to see it for what it really is? The invisible, indispensable backbone holding our entire world together.